Okay, here we are going to be graphing rational functions. You should look through the PowerPoint I have on this 7-8 step process, depending on how you count. It's a big, long process. Here I'm just going to be applying all of those steps. So say we want to graph this perfectly good rational function here. First step we want to do is find the domain. So number one, domain. To find the domain, take the bottom, the denominator, say it's not allowed to be 0. Technically, our first step is factor top and bottom. The only thing we could factor out here is a 3. Nothing's going to cancel, so I've kind of skipped that step. So we take the bottom, set it not equal to 0. X then is not allowed to be 4. So our domain is all real numbers except for negative infinity to 4, 4 to infinity. That's the domain. Okay. Notice I have two different sections of domain. That means I'm going to have two different sections of graph that don't touch each other. I'm going to go ahead and call these guys section 1 and 2 now. I'll need that in a minute. Okay, step 2, find any asymptotes. So let's find any vertical asymptotes first. To do that, we take the bottom, set it equal to 0. Vertical asymptotes, take the bottom, set it equal to 0, and we get x equals 4. That's the same thing we just did right here. Finding the domain, finding the vertical asymptotes are the same work. We just write the answer a little differently. We get x equals 4. Vertical asymptotes are vertical lines, and they're always x equals a number. Okay. I think as soon as you find something, you should put it on your graph. So I'm immediately going to start graphing. I found something, I'm going to put it on the graph. So x equals 4. Drawing a vertical line. All right, there's going to be my vertical asymptote. It's just a dotted line. Okay, next step, find any horizontal asymptote. You can label, don't stress about, well, this is step 1 and this is step 2, and don't worry about numbering your steps. I'm just doing that for ease here. Sometimes I'll call this step 3, sometimes I won't. That doesn't matter. The point is we need to find our asymptotes. For horizontal asymptotes, I look at the degrees. The degree of the top is 1. Degree of the bottom is 1. It's the same degree. So the horizontal asymptote is y equals the ratio of leading coefficients. I take my coefficients here, 3 and 1, and make a fraction out of them. 3 over 1. Which of course is just 3. So my horizontal asymptote is the horizontal line y equals 3. As soon as I find something, I put it on my graph. So here, y equals 3. Horizontal asymptotes are horizontal lines. Y equals 3. Okay. Notice here that my vertical asymptotes separate my x-axis into two regions. All of this stuff over here, that's what I called region 1. And all of this stuff over here. So this whole section, all of this, these x values are negative infinity to 4. That's what I called section 1. And these x values are 4 to infinity. That's what I called section 2. So I'm going to have a chunk of graph over here and a chunk of graph over here. We're never going to cross a vertical asymptote, so my graph is going to either come down like this and approach this vertical, or come up and approach this vertical. Similarly, I'm going to be approaching this horizontal asymptote. So maybe the graph is going to look like this over here in section 1, or maybe it'll look like this. maybe the graph will come up and cross over this horizontal and right on top. But there aren't a lot of choices. Similarly over here, the graph might go like this, right in here in this little corner. It might look like this down here in this corner. It might come from above and cross over the asymptote and then right on the bottom of it. These are all things we're going to check for. But from this moment on, it's really just excluding things that are not possible to figure out what the graph must look like. Okay, so our next step. Honestly, from this moment on, all we're doing is plotting points. Like everything from here on out is basically just plotting points. So the easiest points to find always are intercepts. We look for the intercepts. Okay, so x-intercepts, how do we always find x-intercepts? By setting the function, setting y equal to 0 when solving. So, set the whole function equal to 0. Okay, here's a trick that's going to serve you well. The only way a fraction can equal 0 is if the top equals 0. The bottom plays no role here. 0 divided by anything is 0. So all I have to do is set the top equal to 0. So 3x minus 6 equals 0. 3x equals 6. X equals 2. Now, what am I looking for here? We have to be careful here. I'm looking for an x-intercept. Intercepts are points. If I left it like that, that's a vertical line. Intercepts are not lines, they're points. My x-intercept will be the point 2, 0. So to find x-intercepts, you set the top equal to 0 and solve. Make sure to write it as a point. Vertical asymptotes are bottom equals 0. Intercepts are top equals 0. Okay, y-intercept. How do we always find y-intercepts? Always. We plug in 0 for x. So we'll get 3 times 0 is 0. Minus 6 is negative 6. 0 minus 4 is negative 4. That reduces to 3/2. So my y-intercept is the point 0, 3/2. I'm going to put these on my graph. As soon as I find stuff, I put it on the graph. If you wait until the end, you just got too much stuff going on. It's hard to figure out where all your information is. So let's see, we had an x-intercept at 2, 0, and a y-intercept at 0, 3/2. 3/2 is 1.5, so right there. Okay, now I'm almost done. Think about this for a second. Is it possible that my graph, remember I've got these asymptotes here, the graph is always going to live inside the asymptotes. There's no way the graph could live up here. That's just not possible. Because I've already got these points down here. The graph has to hit these points. So the graph could not possibly live up here, because then I would have points on top of points. I would fail the vertical line test. We're graphing functions. These better pass the vertical line test. So the graph is going to have to live down in this region. Now, it's possible maybe the graph does something crazy, like it goes, ooh, comes down, hits these points, and then bounces back up. So that's the next thing we're going to check for. We're going to determine if the graph ever crosses this horizontal asymptote. So that's, I guess we're calling that step 4 here. Again, don't worry about the numbers. Sometimes I'll number these differently. That's not what matters. This is the order we want to do things in. We determine, does the graph cross the horizontal asymptote? Question mark. Sometimes they do, sometimes they don't. To check that, we set the function itself equal to the horizontal asymptote, and we try to solve. Okay, so my function was 3x minus 6 over x minus 4. My function was y equals that. My horizontal asymptote right here was y equals 3. So y equals the function, y equals 3, the asymptote. Set those equal and try to solve. Okay, this is just a proportion, just a fraction equals a number. I would cross multiply. Take that x minus 4 and multiply it over. 3x minus 6 equals 3. X minus 4. Distribute over here. 3x minus 6 equals 3x minus 12. Okay, solve that. Pause the video. Go ahead, solve that. Oh, something funny happened, didn't it? Those x's cancel out. I get negative 6 equals negative 12. And your first thought is, you did something wrong. No, you didn't do anything wrong. This just never equals this. I didn't say we were going to solve. I said we would try to solve. We couldn't. There's no solution. When all your x's cancel out and you get some false statement like that, that means no, we do not cross the horizontal asymptote. This was a yes or no question. The answer is we do not cross the horizontal asymptote. Okay, and then the last step is plot any additional points you need. Usually, remember how we had our domain broken up into sections? Normally you need 1 point at least per section. I'm going to argue in this case we don't need anything else. I've got enough information to graph this guy. Okay, so let's look at what we have. Remember, you're never, ever, ever going to cross a vertical asymptote. Sometimes you cross horizontals, but here we don't. Is it possible that over here in section 1, this stuff that's not covered, that the graph lives up here? No, there's no way because I have to hit these points. Okay, could the graph possibly do something like this? Come up here and then come backwards. No, that would not be a function. Look at that. If I graph like this, that's not a function. Plus, I have to hug this asymptote. The graph either has to come from above and hug this asymptote from above or from below. So could the graph come up, hit these points, and come on top of the asymptote? No. I just said we're never going to cross this asymptote. That was the last step. So this graph has to hug the vertical asymptote, has to hit these points, has to come down, get closer and closer to this vertical asymptote, has to get closer to this horizontal asymptote. Section 1 is done. The graph has to look like this. What about over here in section 2? Could the graph look similar, be kind of like that reflected over here? Could the graph live right here? Well, if it did, I would have an x-intercept right there. Look, if the graph is in here, boom, x-intercept. I know there's not an x-intercept there because I didn't draw a dot right there. I found all the x-intercepts. There are none right there. Okay, could the graph go like this? Come up and cross over the asymptote? No, we don't cross the asymptote. We've already figured that out. The only possible place the graph can live over in this section from 4 to infinity is up here in this corner. If you can't immediately see that, that's okay. Plot some points. That's the last step, is plot as many points as you need to convince yourself what the graph is going to look like. Okay, so this one is done. That is the graph of that function. Okay, let's look at another example. We're going to do a few of these. Okay, this one's a little more complicated, but same process. First step, find the domain. First step is factor top and bottom and see if anything cancels, but I wrote the question. I know nothing's going to cancel here. Okay, so let's pretend we've already checked to see if anything cancels. I guess technically I'm going to check that anyways because I'm going to take the bottom and factor it. Okay, so we take the bottom for domain. Set the bottom equal to 0, or if you prefer, not equal to 0. Factor. This is x minus 4. X plus 2 is not allowed to be 0. And you can see right there, nothing would cancel, top and bottom. So we get two bad guys. X is not allowed to be 4 or negative 2. Two excluded values. By the way, we also just found the vertical asymptotes. So my domain will be negative infinity to negative 2, union negative 2 to 4, and then 4 to infinity. I get 3 different sections of domain. I'm going to have 3 separate sections of graph that will not touch each other. I need to deal with each of these sections separately. That's my domain. Okay, next step, asymptotes. So let's find vertical asymptotes first. To do that, we take the bottom, set it equal to 0, and solve. We just did it. We get 2 answers. X equals negative 2, x equals 4. The excluded values are your vertical asymptotes. But remember, you have to write it x equals a number. If you don't write it like this, it is wrong. Okay, horizontal asymptote. We look at the degrees. Degree of the top is 1. Degree of the bottom is 2. The bottom wins. When the bottom's bigger, the answer is always, there's nothing to do. The answer is y equals 0. Circle it and move on. When the bottom's bigger, you get y equals 0. I've got some information now. I'm going to put this on my graph. I'm going to start graphing immediately. So what did we have? We had x equals negative 2 is a vertical asymptote. I like to label them. This is not 100% necessary, but I think it's a good idea. X equals 4. Okay. Notice immediately I've got 3 separate sections. These vertical asymptotes are like walls. I've got different rooms here. All this stuff in here, where my hand is, all this, everything in between, and then everything over here. So back here, this is the region, negative infinity to negative 2. That's what I called section 1. That's everything right here. Then I've got negative 2 to 4. That's what I called section 2. That's all this stuff in between the asymptotes. And then all of this stuff here was 4 to infinity. I called him section 3. That's what the vertical asymptotes do. They break your entire xy plane up into different regions of domain. We graph each region separately. Okay, our horizontal asymptote was y equals 0. That's just the x-axis. Y equals 0. Okay, moving on. We find our intercepts. Okay, x-intercepts. To find x-intercepts, we set the function equal to 0. We could write out all of this equal to 0. But again, here's the trick. The only way a fraction equals 0 is if the top equals 0. So all I have to worry about is the top. X minus 1 equals 0. X equals 1. So my x-intercept is the point 1, 0. Okay. Y-intercept. I plug in 0. G of 0 0 minus 1, negative 1. 0 minus 0 minus 8, negative 8. We get 1/8. 0, comma 1/8. That is the y-intercept. Let's put that stuff on the graph. As soon as you find something, put it on the graph. Okay, so what did I get? 1, 0. There. And 0, 1/8. So if this is 1, 1/8 is tiny little fraction there, about right there. We'll just estimate it. Notice later, I'm going to ask, do we cross the horizontal asymptote? Yeah, right there. I know I'm going to cross the horizontal asymptote because I just did it right there. Here's the horizontal asymptote, and I'm touching it. Never touch verticals, but you can touch the horizontal. In fact, that's our next step. And I already know the answer, but let's check it. Do we cross the horizontal asymptote? To check that, we set the function equal to the horizontal asymptote. What was my horizontal asymptote? Y equals 0. So the function itself equal to the horizontal asymptote. And now we got to try to solve this. Remember, the only way a fraction equals 0 is if the top equals 0. So that's the same as saying x minus 1 equals 0. We got a solution. Last time, we got some nonsense, 12 equals 6 or whatever it was. Here I got a solution. So that's a yes or no question. Does the graph cross the horizontal asymptote? Yes. At the point 1, 0. At the x-intercept. In fact, anytime, this is always true, anytime your horizontal asymptote is y equals 0, this question and this question are the same question. Finding the x-intercept and finding where you cross are the same question because you're setting the function equal to 0 in both cases. Okay, so yes, we're going to cross over. Okay, now we can start graphing. We don't have enough information to graph everything, but I'm going to argue here in section 2, I'm done. Could the graph, for example, look like this? Could it look like just a little parabola in between the walls here? No, I have to hit these points. Okay, could the graph maybe come down like this and then bounce back up and then come back down? No, there are no other x-intercepts here. The only place I can cross over is right there. So these two, like for example, have to be connected up. The graph cannot come back down. It has to hug this asymptote. It either has to come up like this or down like this. Those are the only possibilities. I can't get from here and come back down, so the graph has to come up. Similarly, I'm crossing over right here. I'm now on the bottom. I can't get back up here without crossing over again, and there's no place for me to cross. If there were, I would have plotted it. This graph has to write down like this. Okay, what about over here on the sides? Over here in section 1. The graph only has two possibilities. It's not going to cross the asymptote. There are no more x-intercepts. The graph can't like ride from down here and come up and then come over. It either has to live completely down here in this section or completely in this section. Those are the only possibilities. So to determine which one it is, all I have to do is plot one single point. If I plot a point and it lives right here, then the whole graph has to live right here. If I plot a point and it lives right there, the whole graph would have to live down here. Okay, so we plot a point in each section of our domain that we haven't completed yet. If that's not enough to convince you, plot 10 points. Plot as many points as you need to figure out what the graph looks like in these other two sections. But all you really need is one. Okay, so that's the last step. Plot points. Okay, so I've got my 3 different sections here. I need a point in section 1. So in section 1, I want to plot a point here. I just pick an x value. Which one? I don't care. Any x value that lives in this section. So say -3. So let's choose x equals -3. Could have been -12, could have been -4 million. Doesn't matter. Any x value that lives in this section. So g of -3 would be, I'll write it out, -3 minus 1. -3 squared would be 9. -3 times -2 would be +6. And then -8. So what do we get? -4 over 15 minus 8 is 7. Now really all I care about is it positive or negative? Is it above or below my asymptote? But, I mean, we got the numbers, we might as well use them. Let's check my arithmetic. That's right. So that's the point, -3, -4/7. That's enough. That's all I need. So, -1, -2, -3, -4/7. I'm going to label it. Just going to estimate. Okay, there's a point. That's all I needed to get this section of the graph done. The graph cannot possibly cross this vertical or this horizontal asymptote because I checked that already. So my graph has to look like this. Has to ride along the asymptotes. That's the whole point of asymptotes. Asymptotes are just boundaries that steer your graph. It has to live down in this corner down here because I found a point in that corner. Now you may think, this is a common mistake, people think, oh well this one's here, the other one must be up here. It doesn't work like that. I've been doing this for 25 years. I cannot tell you, literally, right now I have no idea if the graph is going to be up here or down here in this other one. You have to actually plot a point and check. There's no way to just glance and look. So now we do the same thing for section 3. So for section 3, I pick an x value that lives in section 3. So maybe 5? Anything bigger than 4 will work. So choose x equals 5. Or 7, or 23.6. Any number bigger than 4. G of 5 will be 5 minus 1 is 4. We get 25 minus 10 minus 8. So we get 4. That would be 15 minus 8, 4/7. Okay, so that's the point. 5 4/7. That's a positive point. My y value is positive. So over here, I just messed everything up. Hold on, let me fix this. Okay, over here we're at the point 5, go over 5 up 4/7. All I honestly cared about is the point up here or down here, above or below. Okay, so now I've got the point. My graph must look like this, has to hit that point, has to hug both of these asymptotes. The graph has to all live up here. That's it for this particular one. It was kind of ugly. They can get a little bit worse, not too much. Okay, another example. This is going to be a long video. Okay, first thing we want to do is factor top and bottom, see if anything cancels. You can see immediately this is x minus 3, x plus 3, nothing will cancel. So we find the domain. I'm going to stop numbering because the numbering really means nothing. Take the bottom, set it equal to 0 and solve. That, of course, is x minus 3. X plus 3 equals 0. We get two bad guys, negative 3 and 3. Again, it doesn't matter whether I write equals to or not equals to, but remember, this is important. The domain is not 3 and negative 3. Those are the excluded values. Those are the bad guys. So to remind yourself of that, it's okay to write not equal to as you go. Then your domain is an interval like this. If you can't go straight from here to writing this in interval notation, that's something you want to practice on. Notice I have 3 sections of domain again. If you have 2 bad guys, you'll have 3 sections. If I had 15 bad guys, I would have 16 sections of domain. So it was 1 more. Okay, next we find vertical asymptotes. That's the exact same work we just did. Like, I'm not going to go through it again. Your excluded values give you your vertical asymptotes. X equals negative 3, x equals positive 3. Vertical asymptotes are lines, not numbers. Horizontal asymptote. Here's where we look at the degrees. Degree of the top is 1. Degree of the bottom is 2. Bottom wins. Anytime the bottom wins, we get y equals 0. We're done. That's the horizontal asymptote. Okay, let's start plotting this. As soon as you find stuff, put it on a graph. So I've got negative 3, 3. It's okay to label these, but it's not necessary. Notice that gives me 3 separate sections. All of this stuff, everything in between, all of this stuff. I'm looking horizontally here. So this is section 1 here, section 2, and section 3. Okay, my horizontal asymptote was the x-axis, y equals 0. Okay, what do we do next? We start plotting some points. We find some intercepts. Okay, so the x-intercepts. Sometimes you have 1, sometimes you have none. Sometimes you have 2, sometimes you have 10. You can have a bunch of x-intercepts. You can't have more than one y-intercept, but you can have a bunch of x-intercepts. X-intercepts, we set the function equal to 0. Set y. Remember, this is y. Y equal to 0. The only way a fraction equals 0 is if the top equals 0. X-intercept is top equals 0. Vertical asymptotes are bottom equals 0. I get x equals negative 5. Intercepts are points, not numbers. This is the point, negative 5, 0. Y-intercepts. To find y-intercepts, you always plug in x equals 0. 0 plus 5 is 5. 0 squared is 0 minus 9 is negative 9. So I get the point 0, negative 5/9. We plot both of these. As soon as you find it, plot it. You wait until you got everything on the page. It's too hard to go back and find everything. My x-intercept was negative 5, 0, right? Checking me, yeah. My y-intercept is 0, negative 5/9. That's a little more than negative a half, so say that was negative 1. About right there. There's my y-intercept, there's my x-intercept. Okay, I'm going to say section 2 was done. Like here in section 2, in between the walls. I don't have any x-intercepts in between there. I know, because if I did, I would have just plotted them right now. There's no x-intercept in there. The graph cannot possibly come and cross over. The graph could not all live up here. It couldn't look like a parabola up here. If it did, it would miss that point. I've got a point there. I have to hit that point. So in between these walls, the graph has to kind of look like an upside down parabola. Remember, you have to hug the asymptotes. The only possibilities over by this guy is the graph comes up or the graph comes down. Because I have to hit this point, the only possibility in between the walls here is for the graph. It's not really a parabola, but it kind of looks like an upside down parabola. Similarly, over here in section 3, the graph has to all live up here or all live down here. It can't cross over because if it crossed, I would have found an x-intercept. Over here, something funky is going to happen though. We are going to cross the asymptote. See, right there. The graph is either going to come from above here, come down, cross over and ride underneath, or the graph will come up this way, cross over, and then ride on top. And the only way to figure that both of these sections out are plot a couple of points. So that's the last step. Just plot some points and see what makes sense. Okay, technically we have to check, do we cross the horizontal asymptote? But anytime your horizontal asymptote is y equals 0, you've already answered that question. I mean, we'll go through the work. Set the function equal to the horizontal asymptote. That's the function. That's the horizontal asymptote. And try to solve. However you want to think about solving this, like you could think cross multiplying, 0 times anything would be 0. Or you could think fraction equals 0 means top equals 0. So you get x plus 5 equals 0, x equals negative 5. I got an answer, so the answer is yes. In fact, I even know where. Negative 5, 0. There's my x, there's my y. But I already knew that. I already knew I was going to cross. I looked at the picture. Okay, so now we plot some points. You're going to need at least 1 point in each section. I already have a couple of points, I have 1 point in section 2. Section 2 is done. So we do section 1. Pick an x value that lives in this section. Any x value you want. I like to choose ones that are pretty. I don't want to use negative 3.27. I chose x equals negative 4. Okay, so we plug it in. H of negative 4. Negative 4 plus 5 would be 1. Negative 4 squared is positive 16 minus 9 would be 7. 16 minus 9 is 7. So I get the point, negative 4, comma 1/7. Okay, now, got to be really careful here. I've got the point negative 4, here's negative 3, negative 4, 1/7. It's like right there. So let's label that. Negative 4, 1/7. So my graph here, you can see it can't possibly cross underneath here. If it did, there would be another x-intercept there. The graph has to come down. I'm going backwards now here. Hit this point, cross over the horizontal asymptote. You can cross a horizontal. Now it's not going to just shoot down here. It's not going to go, woo, it's not a polynomial. This is still an asymptote. But asymptotes only tell you what happens on the ends. So the graph has to ride on the bottom of this asymptote here. It's going to come down a little bit, but then it's going to go back up and ride underneath this asymptote. So it's going to get closer and closer on the bottom. You can cross a horizontal asymptote. You can never cross a vertical. Okay, we play the same game over here. We graph a point in this region in section 3 of my domain. So this is what I'm looking at. Pick an x value here. So in section 3, I'm going to choose x equals positive 4. I like the symmetry. I chose negative 4 here, so I'll choose positive 4 here. But I, again, could choose any x value I want. H of 4 will be 4 plus 5 over 16 minus 9. I'll get 9 over 7. So that's the point 4, 9 sevenths. I put that on my graph. So here's 1, 2, 3, 4, 9 sevenths. Is a little bigger than 1, so come up a little bit here. 4, 9 sevenths. Okay, here I'm not going to cross the asymptote. If I were going to cross it, I would have already labeled that. I've already eliminated that possibility. The graph has to ride along the asymptote. It can't possibly ride from down here, because if it did, I would be crossing over. And I know I don't cross here because if I cross the horizontal right there, I would have already plotted that. So the only possibility is the graph must look like this. And this one's done. So that's what the graph looks like. Okay, let's do one more with a hole. Okay, so now we're going to graph this guy. Our first step, what we're supposed to do is factor top and bottom. So I could factor, say, a 2 out of the top. X squared minus 25. Hey, that's a difference of squares. I could factor that again. 2, x minus 5, x plus 5. And then the bottom, that's x plus 5, x plus 3. Okay, so we factor top and bottom. We check and see if anything cancels. Hey, I have a common factor. Notice I cannot cancel these x squareds. You can only cancel factors, not terms. So you must factor first. Factor top and bottom. X plus 5's cancel. I get 2x minus 5 over x plus 3. But that equal sign that I just wrote is not really true. These two things are only equal if I did not just divide by 0. You're not allowed to cancel out a 0. So who was the bad guy? Who would make this guy that I just canceled out 0? That would be negative 5. So x is not allowed to be negative 5. That means that I'm going to have a hole at negative 5. Instead of a vertical asymptote. Now I just graph what's left over. I graph this thing, and then at the end I add the hole. Okay, so it's the same process. I find my domain. Domain is anybody that makes the bottom 0 is bad. I've already found one, negative 5. X is not allowed to be negative 5. I can just glance and see who the other one is. Negative 3. I have two bad guys. It was a quadratic. Quadratics always have two solutions. I have two bad guys. So my domain is negative infinity to negative 5. Negative 5 to negative 3. And negative 3 to infinity. 3 sections of domain. Okay. Find a vertical asymptotes. We do that by setting the bottom equal to 0, but only in the reduced version. So I had two bad guys. That guy's not a vertical asymptote. He's just going to be a hole because he canceled out top and bottom. It's this guy that's left over that's a vertical asymptote. So the only vertical asymptote I have is x equals 3. Horizontal asymptote. Look at the degrees, top and bottom. I can go here to the original or to this reduced version. Doesn't matter. They have the same degree. They're both x squared. Or here, they have the same degree. They're both a power of 1. So I take y equals the ratio of leading coefficients, 2 over 1, which is just y equals 2. There's my horizontal asymptote. Let's put that stuff on the graph. So I get x equals 3 was the vertical. Y equals 2. Is that what I got? Yep, y equals 2 is the horizontal. Okay, I find intercepts. X-intercepts. Set the top. I could use either version, but I got to remember I'm not allowed to use -5, so let's do everything with the reduced version. Set the top equal to 0 and solve. That 2's not doing anything there. I could just divide out the 2. 0 divided by anything is 0. I get x minus 5 equals 0. X equals 5. So my x-intercept is the point 5, 0. That 5 has nothing to do with that 5. The only reason we got 5s floating all over the place is we had a difference of squares. X squared minus 25. So don't let this 5 and that 5 get you confused. They're not related. Y-intercept. We plug in 0. So I'll get k of 0 is 2. 0 minus 5 is -5 over 0 plus 3 is 3. I think that's -10 thirds. 0, -10 thirds. Let's take this information, put it on my graph. X-intercept 5, 0. That was 3, 4, 5. 5, 0. Y-intercept was 0, -10 thirds. So over 0, -10 thirds is a little more than -3. So right there. Okay, we check and see if we cross the horizontal asymptote. That's a yes or no question. The answer is usually no. In fact, here's a little hint. Anytime your function is linear over linear, the answer is always no. You're never going to cross the horizontal asymptote. But let's check it just for fun. I set the function equal to the horizontal asymptote. So that's the function. That is the horizontal asymptote. And I try to solve. That's a proportion. We solve proportions by cross multiplying. So I'll get 2x minus 5 equals 2 times x plus 3. Just multiplying the x plus 3 over. Distribute. 2x minus 10 equals 2x plus 6. Hey, those two x's cancel. I get -10 equals 6. No, it doesn't. -10 does not equal 6. What does that mean? It means the answer then is no. We do not cross. That's all I needed. I can now graph. Almost. I'm going to have to plot the whole. Okay, over here in section 1, in this half of the graph. The graph can't possibly live up here because I've already got a point down here. Is that point right? And see, these graphs are self-correcting because I just realized, looking here, if my graph lives like this, right here, something's not right because I would be crossing over the x-axis. There would be an x-intercept here. Something's not right. Something must be wrong with this graph because this point must be on the graph If I graph like this, I would have an x-intercept there, and I don't have one. So I paused the video and I went back and looked and realized that right here, the vertical asymptote was not at 3, it was at -3. These graphs are self-correcting. If you make a mistake, things will not line up. So this was not my vertical asymptote. In fact, maybe I'll just get a brand new sheet of paper. My vertical asymptote was at -3. X equals -3. My horizontal asymptote was at 2. My x-intercept was 5, 0. My y-intercept was 0, -10/3. It's a little more than -3. Okay, now this is correct. Now, my graph over here in this section must look like this. It's got to hug both of these asymptotes. It has to pass through the points that I already have. Back here in this section, the graph cannot possibly live underneath, because if it did, there would be an x-intercept right there, and there's not. The only possibility is that the graph lives up here in this corner. Okay, now the only thing left is to put in the hole. Okay, so at x equals -5, right there, I'm going to have a hole. So that's a point on the graph that doesn't actually exist. To find that y coordinate, we plug in into the reduced version. So to find the hole, I do k of -5. I can't plug it in here. If I plug it in here, I get 0/0. That's why it canceled. I plug in here, and I'll get 2. -5 minus 5 is -10. -5 plus 3 would be -2, so that's -20 over -2, which is +10. So I get a hole at the point -5, 10. It says -20. Okay, so that's the last thing I do. I go back to my graph. So back here at -5, up here, right there, wherever my graph happens to be, I'll come over and say that that is up at 10, and I can even say here -5, 10. Okay, that is the graph of this function. Okay, it's just like graphing all the other ones, only we put the whole one at the end. Okay, that is graphing rational functions. This is a long video, but I wanted to go through a lot of examples. Other videos that are relevant should be popping up now.